Hello, in this video I will be showing you how to use XRPScan and generally XRP explorers. So one important thing about XRPScan is you can obviously we're talking about the XRPL, a public blockchain, meaning that all transactions and all validated blocks or well all last close ledgers are publicly viewable, so anybody can look into them. So the current last close ledger is, you can see here, there's number 36,886,777. So about every 3 to 4 seconds, a ledger closes. So meaning like we're calling that the ledger here, so the last close ledger, the LCL. But it's more like you could also call it just a block, or also like for example a Bitcoin network, or also in other blockchains called the height. So for example, if I just enter Bitcoin Explorer, just right there, you can see it's here mentioned as the height. So latest blocks, it's called here the height. So just in comparison, so maybe you remember that or have heard about that. So we can click on a block and on the ledger, and the ledger is basically a set of transactions. So we can see here this ledger contained 38 transactions in this ledger. And the thing here is there are multiple transaction types. So currently the XRP ledger I think knows about 5 to 10 different ones. I would have to look it up though. But let's look at the most interesting ones. There are offer transactions. These offers are part of the decentralized exchange functionality, meaning that you could use the XRP toolkit or also Sologenic or any other decentralized exchange. Whenever you post an order, it is being sent, so you can see from whom it gets sent, and it's being sent to the XRPL. So it's just an offer. Then there's an offer cancel. You can cancel the offer you created, and now we're getting to a more interesting part here, to a so-called payment. That's the most common. So it's not the most common thing, but it's probably the thing you might use the most. It's just sending XRP from one address to another one. So we can see here from coins.ph1, there are XRP being sent to Binance One. So somebody might have sent from one exchange XRP to the other one. So you can see the amount is rather small. So this might be just a person sending from one of his exchange account XRP to the other one. But let's also look at transaction, for example, at that one here. We can see here that a unknown address, so just an XRP address, is sending XRP to another address. So we can see here the person was sending 325 XRP and whatever 386,289 drops. And we can just left click at the addresses. So one thing you need to understand is that also what I want to highlight is that when you use a hardware or a software wallet, then you create your own address. But the important part here is the XRP are not stored on the device. For example, if you have a Ledger Nano S, so I'm just highlighting that here one more time so people don't remember these misconceptions. So in that thing here, the XRP are not stored on there. This is just the access key more or less. This thing remembers your 12 or 16 or 24 word mnemonic. These 24 words which are the master password more or less. This thing is just used for signing. So when it stores the 24 mnemonic, then it does the signing and it sends the signed hash to the blockchain. So it's more or less like your signature, saying yes, I signed this transaction, and then the blockchain knows, okay, it's really you, and you're allowed to do that. And the thing here is that when you're having an account on a exchange, they're using shared XRP wallets. So for example, with Binance, we can click on Binance One here, and we can see this wallet contains quite a lot of XRP, so over 2 million. And this wallet here is like a shared wallet, meaning that when you buy, for example, 10 XRP on Binance, these 10 XRP, they just so nothing in the blockchains changes. They just give you an IOU on the internal database on the website. They're saying, okay, you do own 10 XRP, and it changes something in the blockchain when the first time you, for example, say you want to withdraw the XRP and send it to another address. Then that's the first time you actually interact with the blockchain, more or less indirectly, by telling Binance to do something. So you, for example, create a software wallet like Exodus or Atomic Wallet or whatever, or also using the Xum app. I would also recommend using that one. It's pretty cool. It's a pretty nice app though. And when you do that, you can enter that address and you're sending it, and then Binance is sending that XRP and activating the account if it was not activated before. But for example, let's look at this address here. So we can look at the ancestry. We can see the entire way. So we can see this account was activated on the 1st of May 2021. And who activated this account? It was Coinbase 6. Who activated the Coinbase 6 account? It was Coinbase 2. Who activated that one? And so on. And now there's the interesting part that's go on. And there is, for example, one of these root accounts. So this one is in the Genesis block. So the interesting part here, so we can see it's H Brito, it's Aldo Brito, one of the developers of the XRP ledger. And if we look at that account, so there's nothing on it anymore, so probably due to oh yeah, I read about it on the XRPL website. They lost a few blocks, but never mind. At the creation, so there was like an issue. I would have to look it up, I think, but that doesn't matter currently. So the thing I want to highlight here is we have a tree structure. So in a T, it's quite simple. A tree is just basically a network of nodes, more or less, and we have a root node, so a node at the beginning. So we can also visualize that here. We can see here that Alberto is, for example, on the top. So if we go again to ancestry, so we can see here AH Britos is the core here, more or less, and obviously there's an address, RD whatever, for example, ... Okay, and he can activate, for example, another account, and he did activate, for example, his account for D1 whatever this username, but it also has an account address. It's that one here. So he activates that one here. And that doesn't look good, so I'm just gonna, whatever, D18 whatever, I'm gonna call it that one here. And we get this tree structure that that a root element or a parent element has child elements. And this child element can also activate his own accounts again. So we get a so-called tree structure, which is which is used a lot in a T. So trees are good. So that's just something one of my professors used to repeat at my university quite a lot. So, right, so we get this tree structure there. So on the top thing here is the Genesis block. So these are accounts which were created which do not have like a predecessor. I hope said this correctly. Right? The thing here is that we just get this tree structure, so you can always see who activated which account in which order. So when you want, for example, let's say there's Binance now. And let's say, for example, you've gone into the Exodus wallet and said you want to create a new wallet address. Then you get that address and you want to activate your account. And if you do that, then Binance activates you, more or less. So it's all still in sync with this tree structure there. And people know when you create your account if you tell them your address. So that's we should like. So you could tell people your address, but you're completely transparent. Whenever you tell somebody your address, they just can look you up. It's a public blockchain. But still, right, so this is one interesting feature here on the, right, this is just generally true for most blockchains. So there are some blockchains which do, for example, like Monero, I think, or Zcash, which are completely private, but usually this, like I said, the XRP ledger is a public blockchain. We can also see the metrics for the day. You can see here the current ledger that was closed. You can see how many successful payments were done, how many transactions, how many accounts were created. I think maybe this is for the last hour, or for the current day, probably. Yeah, this might be for the current day. The average time it takes to close a ledger. There's also another website I used quite a lot, is livenet.xrpl.org. On the website, you can see the visualized version when a ledger closes. So you can see here there are like lots of transactions in there. So the blue ones are offers, the green ones are payments, and they're like, yeah, okay, there's like something that doesn't work. Tag unfunded offer. So for example, the amount of the account wasn't sufficient, so that's why somebody could not do an offer. And you can see also like the UNL if it was present here, and see all the validators what they said. For example, this one is okay, yeah. And right, so let's look a little more into it. There's also an own section called metrics. There you can just look at numbers. You can see how many closed ledgers there were. So you can see here, for example, an average we're closing 22,000 ledgers a day. So or you could, yeah, right. And this is quite easy to calculate. Obviously, we just take all these seconds of a day, so a day has 68,400 seconds, and divide it by the number of closed ledgers, so 20,999. 90, and we can see the average closing time for a ledger was, for example, 3.9 seconds. So one ledger closed in 3.92 seconds on average. And we can also see average number of seconds. This is exactly what's being done here. Basically, they're dividing it by it. Right, so there's just some general metrics. We can also see like that how many accounts were activated this day. So on May 28th, we can see 3,000 accounts were created. And also during the times of extreme price action, we can see that, for example, here on February the 1st, and also on April the 6th, there was also like a run up more or less. There we can see that there are lots of accounts were created. So what else is there? We've got also the validators, so that's just interesting here. I already talked about it here today. So you can see here a list of all the validators. The most important ones are these 39, so these are all involved in the XRPL F, so the XRPL Ledger Foundation unique node list, which is being currently used. And we can also see the amendments here. So an amendment just gets activated after enough people vote for it. So when they have 80% consensus, then the amendment gets activated. There you can see the threshold which has to be reached, so the amendment gets activated. For example, as I mentioned in other videos before, something I'm very eager to test is the crypto condition suite. So it's like when you create an escrow, you can add with the crypto condition suite like custom conditions that we'll have to try and play around with it a little. So it won't take that long. You can see 66% voting, so voting for it. So that you can also see a list with yeas and yes and nays. So this is how each feature gets activated. This also helps so the chain doesn't fork. So for example, if the network, for example, doesn't want a certain feature, so they can still update to the new Ripple D server version, but they, for example, would not have to vote for that update. So this is just something that the XRPL Edge is able to like transform and change a lot, but without like tearing the network apart if there's too much a disagreement. So it's also like a great feature, like making it more resilient to forks. So they have been, as far as I remember, I'm right now citing Matt Hamilton. So shout out to him. He's an awesome dev, and I love following his Twitter. Well, it's called battles more or less, or Twitter discussions. And I remember he was talking that there were hard forks. So it is possible, obviously, to fork the XRP ledger, but currently there's like some people tried it, so they were free running, and most projects shut down again. But it is possible, but we don't see that many forks since the network is running smoothly, and they have their own mechanism to activate new features. So it's like not a huge disagreement, so people just vote on it within the system itself, which is awesome. So we can also see here the metrics. We talked about it, the validators and the amendments. So these are the core features. You can just enter here an account name or also an account number. And lastly, I'm also going to quickly show you Bithomp. It's another explorer, so there are multiple explorers. So Bithomp is not, it's like for direct lookups. So for example, you can just take an address, for example, that one here. You copy that and add in Bithomp, and you see a custom visualization of that account. So we can, for example, see here, this account has 633 XRP. We can see the reserve is 60. Somebody might wonder, why is it that high? Usually the reserve is 20. Because for each trust line which somebody has, the base reserve gets incremented by 5. So we can see 1, 2, 3, 4, 5 trust lines. So 5 times 5 equals 25. Plus the base reserve of 20 is 45, and I can bet we have some escrows down there somewhere. So there were probably also some escrows created on that account, but we can't see that here, I think. For example, to see that, we would have to go back to XRPScan, because it also has, so we can just click on escrows here. Nope, not escrows, but there are more trust lines actually. So we can see 2, 4, 6, 8, 8 trust lines, and 8 times 5 equals 40. So 40 plus 20 equals to 60. Base reserve we see here. So we can see here the assets. So we can have the IOUs of Euro, for example. This is just the issues test. We can see here they were testing and messing around with the base feature with that. So we can also, for example, look at the more recent account, which is using these offers. So for example, if we look at that account here, copy the address and add it to Bithomp. There's and enter, click enter here. We can also see, for example, this account uses Chinese yuan, I think. So with the issuer is here iRipple Pay. So it's another company. No, it's not Ripple themselves. Um, and right, so that's basically it. So you can look up all the transactions, check out everything a little bit. You can also see here the activations, which account, which, for example, add a bidder, which accounts he activated. So okay, it's probably taking a little longer here. We can look at the ancestry. Yeah, right. So we can see which accounts he activated. So quite a lot. We can look at the ancestry, which accounts were the first. Yeah, we can analyze. Okay, we can see how much payments were there and so on. And we can see the trust lines, the escrows which were created, and so on. So I hope this video was informative for you. I hope you liked it. Please leave comments on there if you have any questions how it works, and see you in the next video.